Alright guys, so for this video we're going to go over chapter 6 section 1 normal distribution. So the properties of a normal distribution. Now we've seen normal distributions before, so we should recall some of these, and some of these should be new to us. So one is that the normal distribution is a bell-shaped distribution. Also, what we remember about bell-shaped is that the mean, median, and mode are all equal and are located at the center of the distribution, where that line is on the figure below. The normal distribution curve is also unimodal, meaning it only has one mode, and the mode is the mean and the median because they are equal. The curve is also symmetric about the mean, meaning if you were to fold this paper in half using that line in the middle, you would get a perfect balanced shape. Also, the curve is continuous. That is, by continuous, it means it doesn't end, and there are no gaps or holes for each value of x. There is a corresponding value of y, meaning as you go, let's say, from that line down, right, there is no missing x. So every x is accounted for, and for every x there is a value y that corresponds to that x. The curve never touches the x-axis, so when drawing it, it should never touch the x-axis. And the total area under the normal distribution curve is equal to 1, as in 100%, because we are going to be talking probabilities. Alright, so recall the empirical rule. So again, the middle, meaning mu, that is our average. And we remember that one standard deviation to the right, that is about roughly 34%, and to my left is another 34%. And then if you move one more standard deviation, we are going roughly 14% more, so meaning from the middle, 2 standard deviations to the right would be 14 plus 34, that would be 48. That would be roughly 48% of the data lies within that standard deviation. And the rule would be 68, 95, and 99%. Those are the 3 numbers that we should worry about and should care about when talking about standard deviations. Now, the nice thing about a standard normal distribution, so when it's said it is a standard normal distribution, not just normal, so it has to be a standard normal distribution, then the mean is 0 and the standard deviation is only 1. So, what is a z-value? A z-value, or z-score, is actually the number of standard deviations that a particular x value is away from the mean. So what we're saying here is, when I say move one standard deviation away, meaning one z-score away. But in some cases, we may not be moving 1 or 2 or 3 standard deviations. We might be moving 3.2 or 2.1 or 1.6. That would be our z-score right there. And note that a z-value can be used for finding percentages or probabilities. So in this case, we are going to be talking probabilities, but at the same time, it could also be written as percent. When we're talking about probabilities, you times 100 to find the percent. So let's look at some examples to understand what I was talking about. So using the standard normal distribution, so when I say standard normal distribution, that means the mean is 0 and it is a bell-shaped distribution. Find the probability that a randomly selected standardized value from a normally distributed variable is between 0 and 0.95. So we're finding the probability that the z-score is between 0 and 0.95, or the percentage depending on the question. But in this question it said find the probability, so we do not write it in percentage form for the answer. So in this case, if we look at our normal distribution, we'll see that between 0 and 0.95, the shaded area in red is the z-score that I'm looking for. The z-score is 0.95, but what we are looking for is the probability, meaning the percentage that area covers within this normal distribution. Now recall that you see that dashed line right next to 0.95, that is one standard deviation away. Okay, so we know, right, between 0 and 1 is 34.13%. So this answer must be a little less than 34%. So just off the empirical rule, we should know roughly where this answer should be. But how do we solve this? Recall that paper, the handout I gave you, the z-score table that I told you you will be needing eventually, that I printed out. You should have that in hand right now, so maybe pause the video and have that out. So it's called table E. If you can't find it in your ebook, you could just scroll down to table E. So the way you would find the z-score for that particular to find the probability for that particular z-score is by looking at your table, and since we care for 0.95, on the left column is my z, and I would go down up to 0.9, and then what is the second value? 5. So I would go 0.9 to 5, meaning that covers 0.82 or 82% of my data. But that is from the very end of my bell shape. So if you look down on this screen, if you look down to where it says area, so it is telling me that up to that z-score, I have 82% of the data. Up to that z-score. So meaning everything from the left to that z-score, okay, is 82%. But what I care about is from 0 to that z-score, right? So here's the slide. If I'm going all of that, right, that is 82%. That is 82% of my data. However, I care for from 0 to my z-score being 0.95. 0, because this is a standard normal distribution, 0 is my mean, meaning my halfway point, correct? So if that's my halfway point, meaning after 0 is 50% of my data. So if I have 50% of my data on the other end, so how much is left from 0 to 0.95? That would be my 82% minus my 50%, which is 32%. So what's left in between 0 and 0.95 is 32%. Right here. So how much, so what is the probability that my z-score is between, or the score that I'm looking for is between 0 and 0.95 would be 32.32. That is the probability. And if the question was what is the percentage, you would say 32%. So this will just tell you simply what we did, which is the 0.8289 minus 0.5, which means there is a 0.3289 probability for that z-score. Here is another example. So using the standard normal distribution, so again, standard normal distribution meaning my mean is 0. Find the probability that the randomly selected standardized value from a normally distributed variable is greater than 2.3. So keyword greater than. In some examples in between, some examples less than. In this example, we are talking about greater than. So we want to know how much is greater than. So if you go back to a normal distribution, remember from 0, where's my mean, right? Because it's a standard normal distribution. The first dash after my 0, that's 1 to the right. And then it's 2 standard deviations, and then comes 3, but in between 3 and 2 is 2.33. Now I would color the area that I care for, and what I care for is greater than, meaning to the right, so 2.3 and above. So I go back to my z-score, my table E, and I'll find 2.3, and then my next number is 3. So anytime you have a z-score, it is always 2 decimals in. Okay, you never write your z-score more than that or less than that. It is always 2 decimals in. So 2.33, you would find that it is 0.9901. Now keep in mind, again, that the z-score table always gives you from the left all the way up to the z-score itself. So from the left to the z-score itself. But I am not looking from all the way from the left side, right? I'm not looking for over the left side all the way to the z-score, I care for the right side, right? I don't care for the left side. I want the right side of the area because that's where I shaded. So if the entire curve is 1, right, 100%, and right there I have 99%, so I would subtract 100, I would subtract 99% from 100. Or, because this is a probability question, I would do 1 minus 0.9901. So recall, it's from the left all the way to my z-score. But the area I shaded was the greater than. So to find the greater than, think of it as the complement of my probability. So if the complement is 0.99, then what would be my probability? It would be 1 minus the complement. Probability of the complement. So that area, or the probability to be greater than 2.33, is simply 0.0099. So I would do 1 minus. Anytime it is asking for greater than, expect to subtract from 1. Because a z-score table only gives you the left side. So the greater than is always asking for the right side. So now here's another example. However, now we're talking about less than. So because we're talking about less than, we already know from the previous example what I just said is that the z-score gives me the left side. So all I have to do is look at my z-score, find negative 1.51, and that's already my answer. So I care for negative 1.51, so obviously that is the left side, and it's covering the area to my left because the question was less than. Now if the question was more than, then I would color the right side, but because it said less than, I would cover the left side. And then I would go to my negative side of my table E, which is my z-score table, negative 1.5, 1, and I would find that that is 0.0655. Now seeing that the z-score gives me the left side already, right, so I already know that that's it. That is my answer because the z-score already gives me the left side. So anytime it's less than, you simply take what it is to find the probability or the percentage. Now if this was a percentage question, you'd multiply that 0.0655 by 100 and you'd see it's 6.55%. And that is my answer. Probability 0.0655. Alright, now what if we have an example between two different z-scores? So now I'm not talking about the middle or the mean, I'm talking about two different z-scores. So what is, so using the normal distribution table, find the probability that a randomly selected standardized value from the normally distributed variable is between negative 2.07 and 1.88. So I am looking at this area, the shaded area in red, between negative 2.07 and 1.88. So this one's a little trickier because we're talking in between two. Now let's think about this for a second. If I look at negative 2.07 by itself, right, by itself, if I were to look at the z-score of negative 2.07, it would give me that left side. And if I looked at the z-score for 1.88, it would give me the entire left side, right? So if I were to find the z-score for negative 2.07 and then the z-score for 1.88, what is the intersection of those two? It's the middle that I need. But the difference is I would have the extra piece to the left of negative 2.07. So what I would have to do is subtract that side from the probability of 1.88 and I would receive the middle. So what do I mean? So first let's find the z-score for negative 2.07. That is 0.0192. Then after I find that probability, I find the probability for the z-score for 1.88 and I would get 0.9699. Now remember, the z-score gives me the left side for each z-score. So the z-score for my negative 2.07 is that part of it. Okay, it's the left side of negative 2.07. I don't want that side, right? I don't want that side. However, the z-score for 1.88 is the entire. It's from the entire left all the way up to 1.88. What I want is from negative 2.07 to 1.88. So all I have to do is take the 0.9699, that is the entire area under the curve up to 1.88, subtract the left side of negative 2.07, which is 0.0192. So what I have to do is subtract those two from one another, and I would get the area in between, which is 0.95. So pretty much when you have an in-between z-scores, you are subtracting the probability of the right side, so meaning the 1.88, from the left side z-score, which is negative 2.07. Alright, and that's it for this video for 6.1. Thank you. Alright guys, so now we're going to go over chapter 6, section 2, applications of normal distribution. So remember this formula from before where z equals x minus mu divided by sigma, where x is the data value we care for, it is a data value from the data set, minus mu, which is the average of our data set, and sigma, which is the standard deviation of our data set. However, now we will be using table E to find the percentage or the probability. Again, table E being the handout I had given to you guys, which is the z-score table that we used in section 1. So for an example, an adult has on average 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. Now, there are three numbers here that we have to care for and what the question is asking. So number one, the average is 5.2 liters of blood. So that is my mu, 5.2 liters of blood. It says it's normally distributed, so it's a bell-shaped, has a standard deviation of 0.3, so the standard deviation, so my sigma is 0.3, and it says find the percentage, so not the probability, and less than, so from before, less than meaning the left side of our distribution, and 5.4 liters of blood. That is the data value we care for, so that is my x. Now first things first, let's look at the distribution table. So again, 5.2 being the average, so that is the median mode of my normal distribution. 5.4 being the data value that I care for. Now keep in mind, 1 sigma away from the average would be 5.5. So 5.4 is within 5.2 and 5.5, so 5.4 is within the 1 standard deviation. It's in between 0 and 1. So we care for the left side. So we care for that shaded area in yellow. Using the formula from before, so x minus mu divided by the standard deviation, we get 5.4 minus 5.2 divided by 0.3, and we receive 0.67. That 0.67 is my z-score. So hence 5.4 is 0.7 of a standard deviation above the mean. So meaning I have moved 0.67 standard deviations away from the mean, from the average. I go to my table E, I go to 0.6, and then I shift to the 7 and find where how much to the left of my distribution, what is the area to the left of my distribution. So meaning this shaded area would be given from my z-score table, and I would find that the area under the standard normal curve to the left of z is 0.7486. Now of course the question is asking for percentage, so we would multiply by 100 and get 74%, so 74.86%. And when you want to word these, especially on a test or on homework, you would want to understand the context of the problem. Again, the context of the problem is talking about liters of blood. So there is 74.86% of adults have less than 5.4 liters of blood in their system. Alright, let's look at another example. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed. Again, you can't assume normally distribution by yourself unless it indicates and tells you that assume that it is a normal distribution. And the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating between 27 and 31 pounds per month, more than 30.2 pounds per month. Now recall, in the previous section we spoke about in between, less than and greater than, and more than and less than, small than, or smaller than, sorry. When it's in between, if you don't recall, we had to subtract certain numbers between each other, and when we said greater than, which is similar to more than, we also had to do some subtraction. So it's not like this, it's not going to be similar to our example 1 where we simply take the value that's given to us. So let's first start with the between 27 and 31 and see what we're talking about. So the average is 28, so that is the middle point. 27 would be, below 28, and 31 would be above 28. So we're looking for the area in between those two numbers. So again, if I find a z-score for 27, it would give me the left side. And if I find the z-score for 31, it will give me the entire left side, including 27's left side, which means I would have to do what I did in section 1 and find a z-score for 27, find a z-score for 31, and subtract their values. So let's see what happens here. So I would use the formula twice. So the first value I care for is 27 minus the average divided by 2, which is the standard deviation, and I would get negative 0.5. And then my next z-score, I would use 31, which is the second value I care for, and I would get 31 minus 28 over 2, which is 1.5. I go back to my table E. I'll go to the negative side. 0.5 would be 0.50, and I would find the percentage. This question is asking for probability, so I would use the decimal that is given to me. I would then go to 1.50, find the probability that's given to me, and I'll find that the area to the left of Z2, so Z2 being the one for 31, is 0.9332, and the area to the left of Z1 is 0.3085. So the area in between would be subtracting the larger from the smaller and getting 0.6247. Of course, you always subtract the larger by the smaller because an area cannot be negative. So the area in between would be 0.6247. So there is a 0.6247 probability of a household generating an average of 28 pounds of newspaper. So that is the area we're looking at. And the final answer would be the probability that a randomly selected household generates between 27 and 31 pounds of newspaper per month is 62.47%. Now for the second one, more than 30.2 pounds per month, again, the average is 28, so that is in the middle. 30.2 is a little above, right? Keep in mind the standard deviation is 2, so meaning I am 1 standard deviation away, which is 30. So I'm 0.2 away from 1 standard deviation away, so that's kind of an indicator how far I kind of am. That is just me referring back to the empirical rule. So it's kind of important to visualize the empirical rule so you know your numbers are not off when you do the formula. So again, we go back to the formula and we get 1.1, which is reasonable, which makes sense because I just said, because of the empirical rule, I should have known it's a little bit above 1 standard deviation away. So 1.2 standard deviations away makes sense for my z-score to be 1.1. I go back to my table E. 1.1 would be 1.10, and I'll look at the probability that is given to me, and I would find that the probability given to me is 0.8643. Now recall, this is a more than question, more than 30.2, so meaning greater than. So I would have to subtract my z-score. I would have to subtract my z-score from 1 and get 0.1357. So again, greater than is the right side of my distribution, and the z-score always gives me the left side, so I would have to subtract by 1. Again, why by 1? Because the area of the curve is 100%. So if I want to find the complement, which is my right side, to my left side, I would have to subtract from 1. So, hence the probability that a randomly selected household will accumulate more than 30.2 pounds of newspaper is 0.1357, or you could say 13.57%. So the formula for finding the value of a for a normal variable x. So again, the formula is z equals x minus mu divided by standard deviation. So if you solve for x using algebra, you multiply both sides by sigma, add mu to both sides, and then just exchange both sides of the equation, and you simply get x equals z times sigma plus mu. So if given z and sigma and the average, you can find x. So here's a formula. To qualify for a police academy, candidates must score in the top 10%. On a general abilities test, assume the test scores are normally distributed and the test has an average of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Now the first things first is we have the average, we have the standard deviation, and the question is asking find the lowest possible score to qualify. It's not asking for probability, it is not asking for percentages, it is simply asking for the lowest score. So a data point. So I'm looking for an x. And I'm given a few information, however I am not given the z-score. I'm not given a z-score because to find x, I would need the z-score, the standard deviation, and the average. Now I am given the top 10%. So top 10% means at the 10%, if you go up, right, so greater than, that would be the right side of my normal distribution. So let's look at this here. So I'm looking at the top 10%, which is 0.10, right? That is my top 10%. However, subtract 0.1 from 1 to get the area under the normal distribution to the left, right? That would be 0.90. So the area to the left is obviously 90%, which is 0.90. But that's not my z-score, that's my area. So I would have to look at my table E and work backwards. Where is 0.90 on my z-score? If I look at my z-score, the closest number to 0.90 would be 0.8997. Now there is a 0.9015, but 0.8997 is closer. And I would notice 1.28 is the z-score for that value. So 1.28 is my z-score. So I go back to the formula that I found from the previous slide, and I would do 1.28 times the standard deviation, which is 20, plus 200, which is my average, and I would get 225.6, which if you round is 226. Now why do we round here? Because of the context. In some problems we're going to need to understand the context of the problem to round. For example, if there was a problem that had to do with how many people, well, you can't have 0.6 people, so you would have to round up. You wouldn't round down because you always want to go with the safe bet and always go up. So round up in problems like this. For this, for example, a score, you can't get a 0.6 on a score. So you just round up and say 226 would be the lowest possible score to qualify. So a score of 226 should be used as a cutoff. Anybody scoring 226 or higher qualifies for the academy. So you would be in the top 10% and you would qualify if you receive 226 or higher. Alright, that's it for this section.